Today's virtual lesson, is going to be over day 9, writing a good hypothesis. Our objective is you will learn how to write a good hypothesis after this lesson. So for the warm-up today, it's going to be an independent and dependent variables review. In order to write a good hypothesis, you have to be able to identify the independent and dependent variables, or else you won't be able to. So first thing you need to do is, in Canvas, please complete the more independent and dependent variables practice. And if you see how you do on that, if you're still confused, please go back and review the video over independent and dependent variable practice. You'll be confused from here on out if you aren't able to differentiate between the two like a pro. You can access that link Intro to Science Day 9 page. To start off our lesson over writing a good hypothesis, we're going to watch a video explaining exactly what a hypothesis is.
What is a hypothesis? The definition of a hypothesis is an unproven theory or statement, or simply it's a prediction of what will happen in your experiment. To write a hypothesis, you would write if. It is a prediction after all. You're going to change the independent variable, so write this next. Say how you are going to change the independent variable. You're going to increase it or decrease it. Now what? Write what you think will happen because of the change. Use the word then. You are hoping the change you've made will affect the dependent variable, so write this next. How will it change? Is it going to increase or decrease? That's it. Simple. Piece of cake.
So getting into our hypothesis notes, hopefully that video gave you more insight onto what a hypothesis is. A hypothesis is just an answer to a scientific question that is based on observations and data and can be proven true or false. So if we remember the steps to our scientific method of an experimental investigation, before we even have an experiment, we have to come up with a good hypothesis to test. Before we even come up with a hypothesis, we have to come up with questions based on the observations of something. So there are two parts to a hypothesis. The first part is the if statement. The second part is the then statement. So if we put a plant in front of a window, then it will grow. That's a good hypothesis that can be tested true or false. Or we could be more specific, it'll grow so and so inches long. Another way to do that is if we were testing a plant in a closet and we are going to observe whether it grew or not. A good way to come up with a hypothesis would be if we put a plant in the closet, that is a thing we are controlling as scientists, then the plant is not, or it is going to grow. We're going to either prove ourselves right or wrong. So here's an example of the if statements and then statements. The if anything comes after an if is the independent variable. This is stating what the scientists will do in the experiment. In other words, what we will be changing. And this will be the cause of the effect. The cause of a plant growing is if we put it in front of a window. The cause of a plant not growing is if we put it in a closet, a dark closet. That is a cause. Then statement. Anything after then in a hypothesis is the dependent variable. This is what the scientist thinks will happen. This is the result. This is going to be the effect. We either decided or we didn't if it was going to grow or not. Our hypothesis was if we put a plant in front of a window, then it will grow. That will be the effect, it growing. And if it did after the experiment, our hypothesis is true. If we said that if we put a plant inside a dark closet, then it will grow, and it ended up not growing, then that hypothesis would be false. Okay? Hopefully that gave you better insight onto how that works. We will go into more detail. Here is the hypothesis formula. If I do this, every hypothesis we do is going to have an if and then, all right? Anything after the if is our independent variable. If I do this, meaning if I change this, if I do this to whatever we're observing, then this will happen. That'll be our dependent variable. So for example, when we are talking about the plant, if I put a plant in front of a window, that's the thing we're changing. We can either put it in front of a window or we could put it in a closet. We're changing that. Then it will grow. Growing would be the dependent variable because we're saying then this will happen. So here are the steps for writing a hypothesis. We're going to start with the question that we want to answer in our experiment. So in that experiment, we want to know if a plant's going to grow or not, depending on where it's put. So we're like, well, will it grow in a closet? The same as it will grow in front of a window. We're finding our independent and dependent variables. That is the question. All right, it's already presented before we even come up with our hypothesis. Then we're going to write a testable hypothesis. Can we test it? Is it testable? Yes, we can test if a plant is going to grow in front of a window or in a closet. All right. First, we're going to have a question. We probably were observing from this, based off of this question, we're probably observing if we're getting any pimples. And we're thinking about things we eat a lot. Well, if I'm eating chocolate and I'm getting pimples, does eating chocolate cause pimples? So hopefully you see how from there we came up with that question by observing something simple. Something as simple as if we're getting pimples or not. So our independent variable, we already can identify what that is without even coming up with our hypothesis. After this question, we know the thing that we can control from this question is whether or not we eat chocolate. We know we're eating a lot of chocolate. I either can eat chocolate or I won't. Our dependent variable is how many pimples we get. We're going to ask ourselves, is our eating chocolate affecting my skin? Is that affecting how many pimples I get? The cause of us getting pimples would be how much chocolate we get in this situation. So our hypothesis would be if you eat more chocolate, then you will get more pimples. Hopefully from there you can see how we came up with our question first, identified our independent and dependent variables. We know from our formula, our hypothesis formula, that we're going to have if then statement, and literally we just plug in the variables where they go. Our second example, question, is it harder to fall asleep with the light on? In this situation, our independent variable, the thing that we can control, is the light on or off. What's going to depend upon whether the light being on is how long it takes to fall asleep. That's going to be our dependent variable. That's going to be our result in this situation. So our hypothesis is if you leave the light on, it will take longer to fall asleep. So from those examples, one thing I did notice is a good hypothesis. If it's good, it has to be testable. Those things on the last slide are testable things. We can come up with a test. We can measure the results. We can time how long we were able to stay asleep. We can see if eating chocolate gives us pimples over an amount of time. Those hypotheses that we saw on the last slide are testable. So Dawn soap is the best dish soap. From this, I want you to think to yourself, is this testable? Can we test this? Well, the answer is no, we can't test this, so this isn't a good hypothesis. Because this is an opinion. We cannot determine, we can't measure if something is the best or not. That's going to be up to the person in question. A good hypothesis must be something that can be measured and proven. If the temperature increases, then tire pressure will decrease. Is this a good hypothesis? Can this be tested? Well, the answer is yes. This is a good hypothesis because it's first off, it's written in using our formula if and then statement. and it is testable. We could design an experiment to test this and determine if increasing a temperature makes tire pressure decrease. We can have results and prove ourselves right or wrong. We're going to go over some more examples of what makes a good hypothesis. Remember, we have a hypothesis formula. We have it: if I do this, then this will happen. If I do this, we have our independent variable. This is what we're going to do in an experiment. This is what we're going to control, and this is the cause of the then. Then this will happen. The dependent variable, this is what we think might happen, the results, and this is going to be the effect. Remember, a good hypothesis has to be testable. It must be something we can test and measure the results of. If it's not something we can test, it's not a good hypothesis. Our first example: if the flowers are watered, then they will do something. Is this a good hypothesis? Well, the answer is no. This isn't a good hypothesis. Now, it might trick you, like, yeah, there's an if and then, automatically, okay, we have a good hypothesis, but no, it's not a good hypothesis because it's not testable. We can't just say they will do something. They'll do what? We have to be specific and state what the flowers will do. Or else we'll be sitting here all day. Yeah, flowers will probably do a lot of things. What are we testing for? We need to be specific what we're testing for. Are they going to grow? Are they not going to grow? Are they going to bloom? Are they not going to bloom? What are we testing those flowers being watered? What are they going to do? Here's our next example. If the temperature is increased, then the radish seeds will sprout quicker. Is this a good hypothesis? Well, the answer is yes. This is a good hypothesis. First off, it's written as an if and then statement, and it can be tested. We could literally measure temperature increasing or decreasing and seeing the correlation between the sprouts, if it's going quicker or slower depending on the temperature. The independent variable is something that we're changing, so that would be the temperature. We can change the temperature, we can turn it up or down. That is the thing that we as scientists are changing in this experiment. The dependent variable is how quick the sprout will grow, okay, or how quick the radish seeds will sprout. The time it takes the seeds to sprout, that's something that we can measure and we can put down in a data table. So this is a very good hypothesis. Our next example: Miracle-Gro is better than any other plant fertilizer. Is this a good hypothesis? Hopefully you saw automatically that it's not. No, it's not, because we know the word better automatically says this is an opinion, and we do not test opinions. And also, something you should notice, there isn't an if and then. So we don't have an independent variable and a dependent variable. And it doesn't have an if and then, again, because this is an opinion. It's not testable. We can't scientifically measure if something is better than something else. For the next couple of examples, we're going to be given a question, and we're going to complete the already given hypothesis based on the question we're given. So the first question we have is bacterial growth affected by temperature? We know that what's going to go in front of the if is our independent variable, and what's going in front of the then is our dependent variable. So we are going to test this as a scientist. What is the thing that we are going to be able to control? We are going to be able to control the temperature. So if I know I can control the temperature, that is going to be my independent variable, and that is going to be in front of the if. If the temperature is increased, then the bacterial growth will also increase. If you saw that all we did was identify the independent variable and the dependent variable, and we were able to fill in the blanks from there. The cause would be the temperature affecting the bacterial growth. So if the temperature is increased, then the bacterial growth will decrease. Our next question: does exposure to ultraviolet light cause skin cancer? Let's take a look at our hypothesis and what blanks we're filling in. We have our if and our then. If blank increases, then you are more likely to get blank. Based off this question, it might be hard to identify what we can control. So what I'm going to think of first is, what results are we looking for? We're going to work backwards. So I know the results I'm looking for based off of this is skin cancer. That's going to be our results. That's the thing we're going to measure, whether it's by people, how many people got it or not. So I know that skin cancer is going to be my dependent variable. That is going to be after the then in the statement. So if skin cancer is my dependent variable, then ultraviolet light is my independent variable. And I can fill in those blanks from that. So if exposure to ultraviolet increases, then you're more likely to get skin cancer. Our next question, does salt in soil affect plant growth? Let's take a look at the hypothesis we're going to be completing. If blank is increased, then blank will decrease. All right, so first we need to find our independent, dependent variables from this question. What is the thing that we as scientists will be able to control in this experiment? Are we going to be controlling salt in soil, or are we going to be controlling plant growth? Hopefully by now we know that we would be measuring the plant growth, right? So the thing that we would be controlling is the salt in the soil because plant growth would be our results. The plant growth being our results, sorry, that's off. Plant growth being our results is going to be our dependent variable, which comes after the then. So if salt in the soil is increased, then plant growth will decrease. So that wraps up our lesson on how to write a good hypothesis. Please remember you can go back and view this as many times as you need to. You can look up examples. Once you complete this, please go onto Canvas and do the guided practice, the hypothesis guided practice. You can access it to day 9. After that, please complete the exit ticket, hypothesis exit ticket in Canvas. Again, on day 9, if you have any questions, I'm here to help you. And the lastly but not least, you have your independent practice as well today. Over writing a good hypothesis, all on the same page. If you need help, please let me know. Please let me know. And just take it easy, guys.